We're going to go over some from 2.3 in the calculus course, the product rule and quotient rule. This one I'm not sure involves those, but the fourth root of t could be written as t to the 1/4. It's the power over root. So all I did was rewrite this. Now I'm going to take its derivative. And I'm going to do power base 1 less power. 4/4 less than 1/4 is -3/4. Plus 6, and if I want the derivative of cosecant, derivative of secant is secant tangent. Derivative of cosecant is negative cosecant cotangent. So, what do I have? I have 1 over 4x to the 3/4. I won't accept negative exponents, so you have to move it. Minus 6 cosecant cotangent. Apparently these are all t's. I don't know why I made them into x's, but these are t's. So hopefully that's the answer for G prime. Okay, after 47, I think I was asked a product. Oh, it looks like a quotient rule. Let's do ourselves a favor and factor out the constant first. So if I take a 3/2 out as a constant factor, hopefully it just leaves me something simpler on the inside. So to take its derivative, I'm going to write dy dx. I'm going to keep my constant factor out front. And now I'm going to do the quotient rule because I'm taking the derivative of a quotient. Again, I remember it through the chant. You would say the bottom times the derivative of the top. And the derivative of the top is the derivative of 1 is 0. Derivative of sine is cosine. So you have the the bottom derivative of the top minus the top times the derivative of the bottom. What's the derivative of cosine? Negative sine. And it would all be divided by the bottom squared. So again, if this is u over v, it's a bottom derivative of the top minus the top derivative of the bottom all over the bottom squared. Anyway, you'll clean this up a little bit. This is a negative cosine squared. Cosine squared of x. And I think if I was to take this minus and this minus, I could make it a plus. Well, now I'm going to distribute. What is sine times 1? Sine. And what's sine times sine? Sine squared. You might notice that you have a sine squared and a cosine squared. If I take a negative out of the top, I'll go ahead and write the bottom out. If I take the negative out of two of them, would it become sine squared plus cosine squared? You'd still have your plus sign here, right? What could that simplify to? That could become a 1 because sine squared plus cosine squared is a 1. So right now I have a negative 1 plus sine of x. And it's divided by cosine squared. I don't know whether you recognize negative 1 plus sine as sine minus 1, but it's really the same thing. I'm not sure, so can't do much more. If it was sine squared, I believe that's a derivative. Let me see what the book has. Yeah, you're absolutely right. I totally forgot about my 3/2 out front. So everything you have is times that constant factor. So it's going to be this times 3 over 2. Okay, what I'm attempting to do now is I'm trying to match the answer that they have. So what I'm doing is I took the 3/2 out front and I divided both the terms in the numerator by cosine squared of x. So I have 3/2. We're going to have sine over cosine, but I need a cosine squared. And this is a cosine squared. So what is sine over cosine? I believe it's tangent, right? 1 over cosine is what? Secant. So 1 over cosine squared would be secant squared. If I factored out a secant, what would remain if I took these secants away? Tangent minus another secant, not squared, but minus another secant. And I think at this point we've matched their answer. I hope these are equivalent. Again, I'm urging you to try to match your answer because sometimes it takes a little extra manipulation. And it's good to practice it. 31, we're going to practice our quotient rule. It's u over v becomes v u prime minus u v prime all over v squared. But again, I tend to remember it as a chant. The bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Now, many people struggle with the derivative of the square root of x. Square root of x is x to the 1/2. If I was to do power base 1 less power to get its derivative, it would give me this. So if you're wondering where that came from, it's from the derivative of the denominator. So I'm going to rewrite this 3 radical x minus 3x minus 1, but this time it's divided by 2 radical x. And it's all just over when you square the square root, it goes away. What's the opposite of dividing by 2 radical x? Multiply, because I'll never take a radical and a radical. When you multiply here, you get 2 times 3, which is 6. Radical x times radical x, which is x. When I multiply here, they cancel, leaving me what? 3x minus 1. Always use parentheses when you subtract. If you're horrible in algebra, you might do something like that, but you can't. They're not factors. So we have 6x and a negative 3x, which is 3x. I think that's going to make it plus 1 all over x. Oh, I'm sorry, there's more on the bottom, isn't there? It's not just x. What's on the bottom? You have all this stuff, don't you? Wouldn't it be 2x radical x? You got to be careful, like I almost made that mistake by leaving off part of the denominator. Okay, after 31, somebody asked me 51. So to find the derivative of y, you call it dy dx. I'll keep the negative out front. Derivative of cosecant is negative cosecant cotangent. Minus, what's the derivative of sine? Cosine. So I have cosecant cotangent, both of x, minus cosine. And I believe that's the way we leave it. Let's see if it simplifies. Cosecant is 1 over sine. Cotangent is cosine over sine. And this is cosine over 1. I don't see where it's really going to help me to get a common denominator. It's not going to clean it up. So I'm going to imagine this is the answer for 51. I will check. Now I'm going to try to match your answer. It looks to me like you have a sine squared as your common denominator. Sine times sine making sine squared. Top times top would just give me cosine of x, right? And cosine is not over sine squared, so to make it over sine squared, you might multiply by sine squared over sine squared. So what would that make it on top? Cosine times sine squared. I see 2 cosines on top. If I factor out a cosine, what's going to remain? 1 minus sine squared. And what is 1 minus sine squared? Well, we know that sine squared plus cosine squared, as long as the angles are the same, equals 1. If I subtracted sine squared, 1 minus sine squared could be called what? Cosine squared. So cosine times cosine makes cosine times cosine squared makes the numerator cosine cubed. And it's over sine squared. So to match your answer, they're going to break this up. They're going to break it up into cosine squared times cosine. Those are makes cosine to the third. This would be sine squared and 1. So this is cotangent squared and times cosine, which you'll notice is the answer that they ended up with. Again, it's good to practice manipulating them. So I multiplied this by x over x to get this, so it wasn't a fraction, a fraction. Now I'm going to do the quotient rule. The bottom times the derivative of the top minus the top times the derivative of the bottom, which appears to be 2x minus 3, all over the bottom squared. Let's clean this up. This will give me 2x squared minus 6, right? Wait a minute. The bottom is x squared minus 3x, right? So it's x squared minus 6x. The bottom times derivative of the top minus top derivative of the bottom. Yes. Okay, minus, use parentheses and clean this up. What's 2x times 2x? 2x squared. Would that be negative 6x and a negative 2x to make a negative 8x? And last times last, I think, is plus 3. Yes, 2 times 2 is not 2. 2 times 2 is 4. Okay, let's simplify this, however. What's 2x squared and a negative 4x squared? Negative 2x squared. What's negative 6x and a positive 8x? 2x, right? And is this the only constant, minus 3? I believe. Over x squared minus 3x quantity squared. I have a feeling this might factor and perhaps simplify.